ER diagram for relational database. Introduction. An ER diagram shows the relationship among the entity set. An entity is a table name. ER diagram, that is more than one entity. We are going to provide the relationship between those two entities. An entity set is a group of similar entities, and these entities can have attributes. An entity is a table name or attribute of a table in database. Entity. An entity is an object that exists and distinguishable from other objects. An entity is a real-time object. An entity is a table name which helps to store the data. A table contains rows and columns. Rows are called as tuples, columns are called as attributes, and entity always should be mentioned in a rectangle in shape. Entity set. An entity set is a set of entity of the same type that share same property. That is the data of the table. Weak entity. And weak entity which cannot be weak entity is an entity which cannot be uniquely identified by its own attribute. That is, an weak entity does not have its own attribute but it relies on other entity. And weak entity will be represented in double rectangle. By considering an example, college is an entity. College branch is a weak entity. College contains all the data about the college like library, department, branch, students, faculties. Okay. College branch is a weak entity which it does not have its own attribute but it relies on college attribute. It takes the data from the college entity. Same for the weak entity example. Another example is bank. Bank is an entity whereas bank account is a weak entity. Bank entity contains all the details about the customer, bank details, employee details, so and so. Whereas bank account, by taking an examples of attributes like account number and their transaction like deposit or credit, which can be taken from the bank also. That is what it relays. Weak entity which relays on other entity, that is bank. Attribute. An attribute which describes the property of an entity, a characteristics of an entity. Attribute, as I told, entity is a table name. Rows are called as tuples, columns are called as attribute. The column name is called as attribute. Okay. And attribute always should be mentioned in an oval shape. By taking an example of student entity, student is a table name. Student is a table name. Roll number, name, semester. These are all the attributes that should be mentioned in oval shape. Next is types of attributes. Key attribute, composite attribute, single valued attribute, multi-valued attribute and derived attribute. First one, key attribute. It can be uniquely identified. Uniquely is nothing but it does not take any repeated data. The data should not be repeated in an entity from an entity set. Okay, as previously I said, entity is a table name. For example, by considering the attributes like roll number, name, and semester. Okay, name can be same or same. Semester will be same in each class, whereas to differentiate each student will be giving the roll number, that is roll number, register number, employee ID, Aadhaar number. These are all uniquely identified entity, and key attribute should be mentioned in and represented in oval in shape with the underlined text. Composite attribute. Composite attribute is a combination of other attribute, that is one attribute again it is subdivided from that attribute. Name again it is subdivided into first name, middle name, last name. That is called as composite attribute. Multi-valued attribute. Multi-valued attribute which holds the multiple value in a single attribute. It should be represented in a double oval shape in an ER diagram. For example, a person having two mobile contact numbers, therefore it is multi-valued attribute. Derived attribute. Normally we store the data in an attribute, as I said, roll number, name, register number, contact details, so and so. Okay, the table also contains the date of birth. The student, while filling the form, students, they are going to fill the date of birth. Date of birth format will be in date, month, year. By taking these details, we can derive the information. Think this is a stored data. I am going to store the data in the form of date, month, year. Okay, this is derived data. This is derived attribute. Think this is derived attribute. By taking the date, month, year, I can easily calculate the age of the person. I can easily calculate age of the person. That is what this is, a stored attribute. I am going to take the data from the stored attribute, that is called as derived attribute. Relationship sets. Relationship set is an associated among several entities, but it is a mathematical formula to show the relationship between the entities. Teacher is an entity, subject is an entity, it is a relationship. Now we are going to see how to make the constraints among the relationship entities, that is degree of relationship set. It refers to number of entity set that participate in a relationship set. Okay, it involves more than two entities, that is called as degree of 2. Degree of relationship entities involve more than two entity set. By taking some example, in coming slides we are going to see the examples. Mapping constraints. There are 4 type of mapping constraints: one to one, one to many, many to one, many to many. First one is mapping constraint. Mapping cardinalities, that is the number of entities to which another entity can be associated via relationship. First one we are going to see one to one relationship. One to one relationship. An entity A is associated with at most one entity in B, and B is associated at most one entity A. By taking an example, manager as an entity, department is an entity. We provide and relationship managers. This can be user defined. You can give your own name. I am going to provide the relationship. Manager will be 1. Department will be 1. each department has only one manager. That is what 1 to 1 mapping constraint. Next we are going to see 1 to many. A is associated with 0 or more entities, whereas B is associated with only one, at most one entity. By taking department students, I give the relationship has, department has many student. Department will be one, student will be many. This is what 1 to many relationship. Next is many to one. Many to one, that is A is associated with one, most one entity in B, and B entity is associated with more than one entity. That is family members will be having more than one member. Their joint account, they will be having joint account. I can give the relationship as access, else you can give as operate, else you can give as maintain. Okay, family members will be many, joint account will be one. That is what many to one mapping constraint. Next one is many to many. Many to many, A entity is associated with one or more entities in B, whereas B is associated with more than one entities in A. For example, doctor, patient. Doctor, patient. I give relationship has treats. I give relationship has treat. There will be many doctors, there will be many patient, there will be many patient. That is many to many relationship. Thank you.